Hello everyone, it's Mrs. St. Clair, your math queen, where I like to keep math simple and go back to the basics. So we're going to stick with objective 17 and look at example number 2. Please remember we are solving multi-step ratio problems and they are word problems. So we're really going to have to get into this text and use our sauce to create proportions to solve for a missing value. Now, example number 2 is really a meaty, rigorous question, and it can be very confusing. So we're going to break this down and we're going to use visuals to help us do this. So let's listen and read the question. Current law requires that a wheelchair ramp have a height to length ratio of 1 to 12. An old ramp has a height to length ratio of 1 to 7. Its height is 12 inches. Now there will be workers that are going to replace this ramp with a new one that has the same height. So how much longer must the new ramp be to meet the ratio required by law? Wow, let's get into this. Now, we need to pull out some important information from the text. So when we look at this, and let me go ahead and we're going to look at the current law. And the current law says that there is a height to length ratio of 1 to 12. I want to talk about this text because this is very important. It's important because height to length, the height has a value in the ratio of 1 and the length has a value of 12. The order, now this is the ratio, not the actual. But it's important for you to understand that the order, when we write these in fraction form, the order of the numerator on top of the denominator is determined by which one goes first in the ratio. 1 is going to be our numerator and 12 is our denominator. 1 is our height because it is the first number in our ratio. And it gave us the order of the words here in the text. Height to length, 1 to 12. Now, that was for the current law. So we look here and we look at the ratio, 1 over 12. And I put the 1 on top because it goes up first in our ratio. An old ramp has a height to length ratio of 1 to 7. Here we have it written in fraction form, 1 over 7. Height comes first, 1 comes first, so 1 is our ratio value for height, and 7 is our ratio value for length. Now, excuse me. Its height is 12 inches. The height is 12 inches for the old ramp. So the actual height is 12 inches. The workers are going to replace this ramp with a new one that has the same height. So the actual height for the new one, the new ramp, will also be 12. I got all of this information right here in my sauce. So now that I've pulled out my important information, let's use that information in order to solve for. Let's go back and remind ourselves what we're looking for. We are looking for how much longer must the new ramp be to meet the ratio required by law? All right. How much longer? Those words are going to be very important when we get down into the mathematics of this problem and when we try to solve it. The first thing that I would like you to do is to set up a visual of the old ramp first. So if you notice, the text doesn't give us the actual length, but it does give us the actual height. So our first step is going to be finding the length of the ramp. So the first thing I did was use a right triangle to have as a visual as my ramp. Now, the text does give us the height, which is 12 inches, but we don't know the length, so that's going to be our variable. We're going to use the information from our text to set up a proportion to find the length of the ramp for the old one first. So, I now have created a actual, and I could have flipped this and I should have, and I only say that because I always like to put, and this is only personal preference, it's not mandatory, but I personally like to put my ratios on the left side and my actual on the right side. But here I use the actual information and the ratio information on the right. So there's 12 actual inches in the height. Then we do not know the actual inches in length. We do know the ratio of height to length for the old ramp, which was right there in our text, was 1:7. So now I've created a proportion, and you know how it goes. Cross multiply, then divide. Cross multiply, then divide. I love that little jingle. It always gets me to where when I hear it, I know exactly what to do. I can even sometimes just say, and my students will know exactly what I'm talking about. Remember, when you're cross multiplying and then dividing, you always want to cross multiply diagonally, and it's always number to number. If you ever get in a rut and your brain shuts off, remember, we're not going to multiply our number to that variable unless there's a special circumstance that we'll talk about in just a moment. So, here we go. Excuse me. Here, we are going to do 12 times 7 divided by 1, which yields a response of 84 inches. So, and here's my little tip to remind you, always cross multiply diagonal number, then divide by the number not used. So, we now know that the length of the old ramp is 84 inches. Now, remember what that saw said earlier? Let's go back and check. It says, and I'm going to point it out for you again because it's pretty important. It wants you to know how much longer must the ramp of the new one be to meet the requirements measured by law. How much longer in comparison to the old ramp. So we go back here and we're going to do a visual of the new ramp. And remember, the text told us that it has an actual height of 12 inches. And it says how much longer from the old ramp. So that 84 represents the old ramp's length. We're going to have an additional value to add to find out how much longer that will be. So let's check this out. We've now created a ratio of actual inches, and we're going to set that equal to the ratio of the current law, which was 1:12. Remember that? Now, this is where we're going to use our expression and equation understanding. Yep, you got to bring some of that in here too, guys. So, we've always been doing cross multiply then divide. Here, I want you to notice something a little different. Value, numeric value, numeric value, numeric value. When you have your proportions, your two ratios, and they both have numeric values in them, you're now going to do what we call double cross multiply. Yes, you are going to double cross multiply. Okay? Now, again, we are going to use that expression and equation understanding to help us solve. So here we go. We're going to cross multiply 12 times 12. We're going to set that equal to 84 inches plus y times 1. So there's a little bit of some missing information that might confuse you that I need to add here. Give me one moment. So the missing information that I was referring to, when we get down to this equation that we are creating, is the cross multiplication. You didn't see what I multiplied by. So I'm going to go here and I'm just going to freehand draw that, and that will be times, that's my parentheses, Lord have mercy, times 1. So please remember that you're double cross multiplying. Did I lose it? I am sorry. So let's keep that on here until I'm finished explaining. All right, so here we have 12 times 12, which we yielded because of the cross multiplication here, 12 times 12. And then 84 plus y, because that is the length of the current ramp, times 1. 84 plus y times 1. Now, 84 plus y times 1, anything that you multiply, it doesn't matter whether it's an expression or a whole number. It doesn't matter. Anything you multiply by 1, you're going to get the same result, 84 plus y. Now, we are trying to find out what that y equals, okay? And what that y is going to represent is the inches extra that the current ramp needs to be. In order for us to find that, we have to isolate this variable. That goes back to our expression and equation understanding. Remember, in order to isolate the variable, which means get this y by itself, we now must look at what's attached to it, which is a positive 84. To get rid of a positive 84, we're going to subtract 84 or use minus 84. Whatever we do on one side of the equal sign, we must do the same thing on the other side of the equal sign. So minus 84 here, minus 84 here. 84 minus 84 is 0. We've now isolated that variable. 144 minus 84 is 60. Now, this is misset. This isn't correct, actually. The length of the new ramp is 60 inches. That's not true. The length of the new ramp is not 60 inches. The length of the new ramp is 144 inches. But if we go back up to our text, it doesn't ask us for the length of the new ramp. It says, how much longer must the new ramp be? Now, that's why 60 inches is our correct response. Because if you look here, 84 plus y is 84 plus 60. That's the entire length of the ramp. But how much longer is the new ramp from the old ramp? It's 60 inches longer. So our response is A, 60. I'm Mrs. St. Clair, your math queen, where we try to keep math simple and keep it back to the basics. Take care.